Hello, this is our Capstone Senior Design Showcase video for our project, which was to design a mechanical chicken harvester. Our group members were Hunter Lambert, Thomas Graser, Niko Kangas, Haley Selsor, Ashkon Bakhtiari, and Brett Davis. Broiler chickens are farmed in large industrial farms and need to be transported to processing plants. This is usually done via manual labor, but some catching machines exist, but they have certain drawbacks. Our goal is to design a mechanized system that improves on the current models. Initially, we visited a chicken farm and observed hand catching in person. We also interviewed a catching foreman. We then researched existing machines and brainstormed ideas. We used a decision matrix to arrive at our final concept and made sketches and CAD models of it. We were going to build and test our prototype, but the COVID-19 pandemic changed our plans. We switched gears and made a 3D Autodesk inventor model and animation of our working design and hypothetical testing instructions. Here we have shown 4 different concepts that our team brainstormed. We have an inclined conveyor, a lawnmower style frame, a spinning rubber bristle catcher, and a rotating hook catcher. Here we have our catching decision matrix, which shows how we weighted the different qualities that our machine needed to have and how the concepts stacked up to one another. It can be seen that the inclined conveyor concept won and is the concept we moved forward with. Our solution to harvesting chickens is taking proven concepts from existing harvesters. Our design is optimized for a single operator and will be simple enough to learn without any extensive training. We foresee several harvesters used in tandem to match the catching speed of current hand-catching crews. Here's a picture of our small-scale model made from the erector sets. It gave us and our sponsors an overview of what we were trying to build. And here's our fully realized final design that we created and rendered using Autodesk Inventor. At the beginning of the semester, we were able to build the base of our design, which consisted of a wagon capable of holding the weight of the coop and other parts. Here's our conveyor design, which consists of a conveyor belt that is 20 inches wide with rough top surface run over a prefab roller set at a 20-degree incline. There will be a drive roller and tensioning roller and a single metal chute that will keep chickens on the conveyor and in a single file line. The motor we are using will be linked to the drive roller using 2 sprockets and a chain. Our prototype used a 0.5 horsepower variable speed motor with a 1 to 3.56 gearing ratio in order to run the conveyor at a comfortable speed to not harm the chickens. Our coop is a manufactured chicken coop that will have chickens loaded in from the top hole. This coop is not the current standard for loading chickens in the US, but is suitable for controlled atmosphere stunning, which is a more humane method of processing chickens and is likely the future of the industry. Our testing procedure would consist of using sandbags and water balloons to determine how the conveyor operates, how much weight it can handle, and how much damage does it cause to the chickens. After determining the safety hazards, we would have gone to a UGA poultry farm to test how well it actually catches and loads chickens. It is difficult to fully evaluate our design since it is not constructed, but if it were constructed and improved upon to include features not in our proof of concept to be used commercially, it would cost around $10,000. We project that there would be 5 to 7 of these working simultaneously, making it much cheaper than the Apollo harvester. There would be less physical demand on laborers while also not sacrificing efficiency. Our design will be able to mechanize one of the last remaining processes that require manual labor in chicken farming. Here is a video showcasing our design model in Inventor, where you can see all the components and how they fit together. You will also be able to see a simulation of our prototype lifting a box, which represents a chicken, up the conveyor and guided by the chute into the loading coop.